you what I've built in a little more than a week. It's time for my capstone. Here are the links for the GitHub and the Hackster if you wanted to dive a little bit deeper into this project and see like the wiring schematics and some of the code and everything. And I do ask that you please hold all the questions until the end. And today I will be talking about why I built a smart desk, what my vision for it was, and how I went about bringing it to life. I wanted to make a smart desk for a few reasons. First, I recently started working from home and at a desk, two things I'd never really done before. So I started to look around for a good desk setup, and I wasn't really that impressed with what I found. And the second part is my wife and I have an epoxy art business, and we're trying to start building epoxy river tables, and we really want them to be smart standing desks. And so I thought that it'd be great to make a prototype and see what I actually needed and what could be improved upon for a first production model, if you will. And thirdly, I see a need in the near future for a solution to the hybrid work from home problems of sharing an office while at the same time not wasting the space. A few of those problems are that when people go into the office, they're going to need a spot with secure storage, and it's going to need to be available when they go in. It'd be terrible to show up and your desk is being used that day. And then with less people around, it'd be nice to kind of personalize your environment a little bit to your preferences. And then lastly, it's been kind of odd, but I've found it hard to stay hydrated because I'm not really moving around as much as I used to. And so I don't feel like I need to drink water. So that was something I wanted to try to address with this. Here you see a picture of me laying out what I wanted in the smart desk and where I thought it should go. The first piece of the smart desk is the fingerprint scanner. With it, you can say have 2 or 3 sets of drawers, and when the correct user comes in, you can unlock their drawers with the fingerprint, and then the dashboard can be notified who is there and what desks are actually open for use in the office. Next are the background lights and the calendar. The background lights flash to remind you to stand up when it's lunchtime, when it's break time to go home even. And the calendar shows the current day, and it can be used to show days when you have a meeting coming or the next day that you have the desk reserved. The touch screen are a great way to interact with technology. And with this screen, you can set the lights, check how much water you've got left, and one day add events to the calendar and add more people to the fingerprint scanner. The load cell is how I keep track of how much water is left in your water bottle and how much you've been drinking. And with the ambient light sensor, the background lights adjust to make sure that you have enough light to not strain your eyes while you're working if it's starting to get into the evening. And then one very convenient feature is the wireless charger for your phone. It slowly charges your phone to protect the battery, and you don't have to worry about forgetting to plug it in, or worse, forgetting to unplug it when you try to leave. And the final part to touch on is the Adafruit Dashboard. And here's where you can remotely check how much water you have left and track how much you've been drinking. So this desk started life as a regular old dumb desk, but I knew it could be more. I used a particle argon microcontroller with built-in Wi-Fi and Bluetooth to control the NeoPixels, load cell, fingerprint scanner, and the touchscreen. I used SPI to control the display part of the touchscreen and I2C to control the touch part of the touchscreen. The load cell, NeoPixels, and ambient light sensors used a mix of analog and digital reads and writes to work. And the load cell information was sent over Wi-Fi to the Adafruit Dashboard. And the fingerprint scanner used UART to communicate with the microcontroller. And all of this was done with C++ written in VS Code and JetBrains CLion. These are a few pictures of the build process. It involved a lot of routering and the use of the CNC laser cutter. And we'll start the video of the desk in action, and then we'll go over a few details of the build and its current functionality.
Hi, I'm Russell Brazell, and this is my smart desk. So the smart desk starts by booting up and getting the wireless connection to the internet and to the particle dashboard, where it then runs a program to check the day, and that way it can light up the calendar with the correct day. The touchscreen starts with a nice welcome message, and then it goes to the home screen. The calendar gets the day and displays it, which as of today is the 12th. The home menu consists of 4 buttons: the lights button, the water scale button, the calendar button, and the fingerprint button. We'll begin with the lights menu. So you just touch the lights and the light menu comes up. Here you can turn on, turn off, change the color, and adjust the brightness of the background lighting. And then from here we go home. You can't tell from this shot, but every time we change the color, it changes on the screen and it changes the background lighting to match. Furthermore, we can adjust the brightness up or down in 5 different levels. We can also completely turn off the background lighting and turn it right back on to the color that it was and the previous brightness. Next, we'll go to the water scale menu. Here, you can see that we have our display for how much water is left on the scale, and we have our Calibrate Scale button. So we'll go ahead and push this Calibrate Scale button. This brings up the instructions on how to calibrate the scale. So now's a good time to go take a look at the scale. This is the water scale. It uses a load cell and a piece of acrylic cut in the shape of a water molecule to figure out how much water is left in your water bottle. To calibrate it, you start on the calibration screen and you place an empty water bottle on the scale. So we'll follow the instructions on the screen and we'll push the button, and right now it's calibrating the scale, and once the home button lights up, you're good to go. So now we'll push home and we'll go put some water in the water bottle and see how much is in there. This screen shows the fluid ounces left in the water bottle. The desk also has wireless charging built right in. This is the fingerprint scanner. It works by simply just pushing it and you're done. This is the ambient light sensor. It takes readings throughout the day to adjust the background lighting to increase at night so that you don't get too much eye strain.
So from here, I'll go ahead and start with the dashboard. And here's the Adafruit dashboard. And I currently have a little more water than yesterday in my water bottle. And with the color picker, this will eventually control the background lighting so that you can set it to whatever background color is your favorite. You know, if you're feeling purple or red or green, you can go ahead and change that. And then this is a graph showing you how much water you've been drinking. As you can see, I haven't been drinking very much today. So I probably need to go get a little water after this. The information on the dashboard is sent over MQTT from Particle, from the Particle over Wi-Fi using MQTT. As it sits right now, there's about 1,350 lines of code, mostly due to C++, not really being made to make these kind of menus like this. And I kept track of all of this code with Git on GitHub to switch between my desktop and laptop for coding on the go. The fingerprint scanner works to enroll and check fingerprints, but it doesn't yet do anything in this version of Smart Desk. The calendar does display the current day. However, the menu isn't fully implemented to the point where you're able to add your own events. And if anyone has